rectangle measuring 8 1/4 units and 3 3/4. Okay, so let's write this in terms as an improper fraction. So that's 33/4, and that's going to be 15/4. Okay, the key here is to look for a common factor between these two numbers, from top or the bottom. Okay, so you can see that we have a factor of 3 that's common up in 33 and 15. And the bottom is 4. Okay, so actually let me rewrite this as 3 times by 11, 3 times by 5. So we can actually factor that out. You get a 9, 16 times by 11 times by 5. So what this is telling us that if you have a tile that's 3/4 by 3/4, which will get an area of 9/16, we can make a 55 of those to get the same area as this. Now the question is, can we make it bigger than 3/4 by 3/4, right? So there's actually no other common numbers that we can factor out from this expression here. Okay, because if you make it any bigger, then this becomes a fraction in value. So if you, for example, put a 2 here, then we have to divide one of these two numbers by 2 to get the same area, right? Then it's not, so we cannot have in here a fraction value because we want to know a square. Okay, a square, we want to know how many of these tiles we need to create the same area as the big tile. The question is how many. This has to be a whole number. That's why we cannot factor out anymore. So this is the largest possible square tile that we can use to fill this larger area.